Hello everyone, I am Chirag Bellara, a junior data scientist for the Laboratory of Data Science at Purdue University, Fort Wayne. In the last video, we talked about what digital twins are and where did the concept originate from, and what is the framework of a digital twin. In today's video, we will be talking about the applications of digital twins in the industry, some challenges and limitations that we face while developing and researching into the field of digital twins. A short recap about what exactly was a digital twin. A digital twin is nothing but a virtual replica of something that exists in the physical world and gets constantly updated with real world data from its physical counterpart. And the digital twin uses machine learning and simulation techniques in order to run analysis and provide real-time insights about the working and the behavior and the reaction of the physical object to various parameters and environmental and any changes in general. Now, coming to the digital twin application of digital twins in the industry, we will be covering four major industries. Digital twins have been proven to be effective in almost all aspects of an industry. We cover four of them here. So first, the healthcare industry. So in the healthcare industry, a digital twin can be used for providing personalized treatment and therapy, for researching into new drugs, new and like experimenting with these new research techniques and new drugs. It can also be used for providing education and training, which is more realistic and more objective. Also, we can use the concept of digital twins for like designing the facility in such a way that it's the most optimal and provides the fastest response time. Several companies have been researching into the possibility of creating digital twins of human organs with the goal of better understanding the intricacies of the functioning of the human body, and also with the hope that this might bring us closer to creating medicine that is personalized and it effectively targets the particular system in our body that requires healing rather than giving a more generalized solution. So that's essentially the goal of using digital twins. That is essentially one of the goals of using digital twins in the healthcare industry. There are many companies that are researching into developing a digital twin of the human heart in order to effectively study and understand how can we treat any illnesses of the heart better. Not just that, we have companies that are researching into developing a digital twin of the entire human body so that it essentially gives us better understanding and more scope for experimentation, for more scope for understanding and learning more. There are a lot of use cases of digital twins in the healthcare industry as such. Moving on, the manufacturing industry. In the manufacturing industry, we consider when we think of creating a replica of something in the manufacturing industry, the first thing that comes to our mind is it will help us customize designs. It will help us uh, work with various design patterns and then figure out which one works the best for us. It also helps, digital twins will also help reduce wastage because we are essentially, the goal is that we experiment on the digital twin and then implement the most effective one that essentially reduces the wastage that's being produced by the experimentation. Um, smart factories are like an area of research in manufacturing that is developing and it's gaining more and more attention over time. These smart factories are essentially use the concept of digital twins to create replica systems that help us experiment with different possibilities and test out strategies before implementing the most effective ones in the real world. Digital twins also help us ensure high quality standards. Now, how do they do that? So, essentially, what happens is we experiment on a digital twin, we run our research techniques and figure out the most optimal outcome. Now, the digital twin knows the process of creating the most optimal outcome. It transfers all the parameters and all the necessary conditions that are required for the most optimal outcome onto the physical system, and the physical system learns from this. So now the physical system is capable of creating the most optimal outcome at all instances, ensuring very high quality in the services provided, the products produced. Not just that, a digital twin will also help us effectively monitor the performance of its physical counterpart, and we can step in whenever we feel like there is a need of a maintenance, or we feel like something's going wrong. We have a constant real-time program that's checking for defects, for malfunctionings. So this essentially helps ensure good quality, reduce wastage, and produce effective and cheaper products in general. Going to the architecture industry, if you have seen the previous video, we talked about Digital Singapore, which was essentially a virtual copy of the entire country of Singapore. Um, the project was launched in 2014, and it was one of the first applications of digital twins in the architecture industry. So digital twins in architecture industry help us provide, uh, mm, again, to provide monitoring, to manage any issues that we feel like are happening right now. It gives us the possibility of ensuring high quality, and it gives us a view of how the whole project would go, so we can plan the project accordingly. So digital in Singapore, which was a project that was launched in the year 2014, was the goal of the project was to create the replica of the entire country of Singapore. And it was designed with the thought that this project would help the authorities make better decisions about the layout of the country, the placement of public parks, for hospitals, for fire stations, police stations, and also not just that, it would also help manage traffic and sewage systems to essentially, it gives us a view of the entire country, and we can experiment with multiple layouts, multiple placements, and then see which one works the best. Going to the automotive industry. So, in the automotive industry, again, digital twins help us provide us with customizations, defect detections, monitoring, and predictive analytics. We all have heard of the company called Tesla, and we are all well aware that the entire system of a Tesla is highly digitized. So basically a Tesla vehicle uses several digital models where each model caters to a very specific uh, physical uh, system present in the vehicle. So for example, the battery pack model, which is one of the biggest selling points of a Tesla, the battery pack model is a digital model of the actual battery in a Tesla vehicle. The model gets updated with the data from the physical counterpart and uses this data to predict battery degradation rate, the remaining miles on the current charge, the wear and tear of the battery, and it also performs some predictive analytics and predictive maintenance to ensure a longer lifespan of the physical system itself. So one of the high selling points of a Tesla is essentially derived from a digital twin. But as we talked about, so we all know that with innovation there are always some challenges and limitations that always accompany such innovations. So digital twins have their own challenges and limitations. The first that we talk about is the data privacy and security issue. So, sorry, yeah. So the amount of data that a digital twin requires is immense. And this always raises the question of data privacy and potential security risks. Also, um, as we know that the digital twins has gained attention in the past decade, which so because the time given to research and development of digital twins is not that much, we do not currently have any standardized procedures or standardized units that have to be used when developing or researching into digital twins. This lack of standardization makes it very difficult for the various academics and researchers to share their knowledge. And not just that, we talked about that digital twins are used in the healthcare industry. So we are essentially providing the all the data of a human body to a digital twin, to a machine. So this always raises the question of, is it really safe? How far are we willing to go in order to get better results? And questions like that. The next comes the interoperability issue. As I said, digital twins have gained a lot of attention in the past decade. Before that, we've always used just normal physical systems and some sort of predictive analytics on the side. Because of that, because all our focus had been on um, having a separate system which acts as the physical system and a separate system which acts as the digital counterpart of it, and both of them don't essentially communicate that much. Everything that we have that has been developed until now is developed with that system in mind. Now, digital twins use both of them together. So, migrating our existing knowledge from a separate system onto a digital twin is is a big task, and there have not been any uh, ways or methods or set protocols that have to be followed in order to have a smooth migration. So interoperability has become a big issue. However, in the recent years, many researchers have published their studies on what what could be possible solutions to these. Uh, Another, I think, when we talk about interoperability, the lack of standardization also adds to the problem, because since there are no particular standardized ways that need to be followed, interoperability becomes more difficult even amongst digital twins that are produced by two separate parties. So next comes the cost of operation and maintenance. So digital twins definitely reduce the cost of operations in the long run, 100%. But the initial cost to set up a digital twin is very high. This cost can be afforded only by big organizations and prestigious institutions, and thus this restricts the scope of innovation in the field of digital twins. Last, we talk about the ethical considerations. A digital twin is an almost perfect replica of a physical system. With the use of digital twins in let's say, the field of healthcare, um, the question is it really okay to provide a machine so much information about a human body? Or anything for that matter, if you talk about, let's say, financial institutions, is it okay to provide that much information to a machine for about, let's say, a bank? So, ethical considerations have always been one of the biggest topics of discussions when it comes to any technology related to machine learning or AI or even digital twins for that matter. So, the question really comes down to is how much data is enough data before a digital twin would actually cross the boundary from the digital world into the physical world. So that's all from my side. This work has been supported by the Laboratory of Data Science and the Indiana Data Mine Grant, and supervised by Professor Alessandro Selvitella at the Purdue University, Fort Wayne. Thank you.